Well, hello once again to another Banggood kit. Obviously, we're a Banggood thing. And it's actually another clock, although you wouldn't know it because there's no LED display, but there are LEDs. And they are 10mm LEDs, each one containing many colours, of which there are, what, 6 altogether, I think it is. And you actually read this particular clock knowing what the colours mean in terms of digits. Apparently it follows the same colour coding as the resistor bands. So if you're into electronics a bit, you'll understand that on old style resistors they got coloured bands on them, and they depending on the colour will tell you the value of it. And I can never remember those values, so frankly this is probably wasted on me, but never mind. I think most of the kits are in some shape or form. But anyway, what have we got? We have got a circuit board, we have got a bunch of components, of which most or many of them are surface mount. I haven't done well with surface mount recently. The last surface mount clock I made, I completely cocked it up and screwed the chips up, so which is the multicoloured display, which I was really upset about because that looked like an awesome kit. However, I have ordered another one because I really want to get one of those working, so hopefully I'll be onto that shortly. But there is a lot of surface mount stuff. You can see here the two main problems are going to be these two chips, so we shall probably do those first because they're going to be the fiddliest, and you don't really want components either side of them while you're trying to get these on, because you want a nice free open area to be able to manipulate them. So they'll be the first thing that goes on. These are, as I say, the 10mm LEDs, and each LED is covered by a glass vial, or whatever you want to call it, which you need to stick down on the PCB. And then this is another piece of protected covered acrylic, which will sit underneath there to protect the electronics. And there you have it. It's also interestingly got, if I can find it here, yeah, there it is. It's actually got a mercury switch, because so yeah, there you go. And you can see the little ball of mercury in there. And that is basically orientation, because if you turn the clock upside down, it works in a binary configuration. So if you understand binary, then great. If you don't, then yeah. So the first thing to do is to get the chips soldered on. As I say, it's all surface mount and they're quite dinky, and I haven't had much luck with those recently, so prepare for another failure. But I shall sort out the components over here and try and put them together as neatly as possible. There's quite a few capacitors and resistors here. The instructions for this are on the item page on Banggood website. You just click on it and it downloads, or you can download a PDF or whatever. And actually it's written in very clear English. Very clear English. The actual Banggood item itself isn't, but the instructions are, so that's quite good. Any road up, what I need to do is I need to sort out my soldering iron and other peripherals, what I need to build this, and we'll start constructing. Alright, so I've set you up there to try and see what's going on through the magnifying glass, and as is usually the case, I'm going to solder one pin just to hold the thing in place and then solder the remainder afterwards. In terms of orientation, you can see just there's a little notch on the silk screen, and you need to correspond it with that dot, so it goes in this orientation like that. And yeah, so what I'm going to do is first of all put a bit of solder on that pad there. Hey, there we go. And then reheat it and offer up the chip, and hopefully that will be enough to hold it in place, which it is, just needs a bit of adjustment. And there we go. So let's have a look. Those pins pretty much line up with the pads. Good enough, I think. They're nice and flat on the board, although not quite on this side, but it doesn't matter because I shall press down on it when I do it. And yeah, so let's try and lighten up as a little bit better. Yeah. It's not quite there, is it? This is where I cock it all up and should just leave it alone. Ah. A bit too far that way as well, isn't it? Do you know what? That'll do. I don't get it too precious about it. The main thing is probably not to hold the iron on the chip for too long if you can possibly help it. I'm going to see if I can magnify that a little bit more. Mainly because my eyesight is complete shoot. I'm struggling to do this through the camera. Ugh. Now that was awful. There's too much solder on there for starters. So what I need to do, I think, is just remelt it and... Oops. No, that was a bit silly. Let's try moving it back again. Hold down a bit more firmly this time. Remelt and flick. Like that. And that, hopefully, will mean I've got most of that solder blob out of the way. A little bit of flux. That's a permanent marker. That's not going to work. That ain't flux. Where's me flux? I had a tidy up, and of course now I can't find anything. So where's me flux? There it is. Okay. I might need to solder these off camera because I just can't get close enough. But it's a little bit of flux. Not be too much of anything, but there you go. And hopefully that will allow the solder to flow directly onto the pads. So I'm going to try and do this off camera because my eyesight is rubbish. Right, so they're soldered on. I've done both of the chips. Where's the other one? There it is. I've done both the chips. I don't know how close I can get in to let you see. There you go. And I have inspected them with a jeweler's loop, which is one of these things. As a jeweler's loop. And the one I use for the purposes of this is a 10 times, or some people call it 10x, meaning it magnifies the image by a factor of 10. So 10 times. 7 times might do you, but these things are dirt cheap. You can get them off of Amazon or eBay or whatever. And I just use these to inspect. I don't know if this will work on a camera. I think I've tried this before. But is that working? Kinda. And just to inspect each pin to make sure that it's soldered correctly. Looks a bit mucky there because of all the flux. I can clean that off with a bit of isopropyl alcohol, which I shall do later. In the meantime, we've got all of these resistors to do, and we have got these capacitors to do, and you'll see that on the silk screen each resistor is numbered, each capacitor is numbered. In fact, you've got lettering for all the components. That's the battery holder and the buzzer, horrible buzzer. These two are touchpads, by the way, literally touchpads, so you can, in this case, set and add. Well, I mean, that's adding means probably increments, and you can see here that the different displays. These two will be for the hour, these two will be for the minute, these two will be for the seconds. The alarm is set, I think, probably, well, you can see here, and it says, does that say bin? Oh yeah, bin, binary. And what that means is turn it upside down, and that will invoke the Mercury switch and it will convert to binary. Very strange. Yeah, anyway. I shall persevere. Now what I'm going to do next is all the resistors and the capacitors, because they're very, very tiny components. I think what I'll do is I'll show you me soldering one of them and how I do that, and all the others will be the same. As I say, when you go on to the item description on Banggood, it will give you a link to the instructions, and the instructions will tell you what values each of these resistor numbers are. So let's have a quick look. Let's see if I can get in here. I don't want to move the camera about, otherwise I'd show you the screen of the computer so you can oh, for God's sake, come on. You just love Windows, right? So resistors 1 to 13 are 120 ohms, and the actual number is 121. So we're looking for a set of resistors with the number 121 on them. So not them, that's 103. What have these got on them? 121, there you go. 121. So these are the guys that we need, and as I say, 121 is for resistor 1 to 3 and for resistor 12. So resistor 1, 2, 3, so those three, and then resistor 12, which is just there. So the way that I think the first thing I shall do is take that out of the packet, and these are apocalyptically tiny, as you'll know from many of my other videos, that these things are smaller than a grain of rice, very easy to lose, and they've given us exactly the number that we need. And I say that because quite often they give you more on the basis that people really lose them, which is understandable because they are so tiny, and they give people a few spares. So at any rate, let's first of all have a look at this under the microscope. Not a microscope, it's a magnifying glass. So why I said microscope, I don't know. Probably because I'm an idiot, but there you go. We can debate that later. Right, here trying to do two things at once. Right, I think we are in focus. I need to move it up slightly so I can see it. If I can't see it, it's all going to go horribly wrong. So, clean off my soldering iron, and we are going to be doing resistor 1, 2, 3, and resistor 12. Okay, so that's half of the pads covered. So the next thing, using a pair of tweezers like this, you still in focus? I think so. Is offer up the resistor, melt it one side, let it touch very briefly, put some pressure onto the component, reheat it, and that makes sure the component is nice and flat to the PCB. And then I'm going to do that for all the others. And these are resistor numbers 1, 2, 1. There we go. And with resistors, it doesn't matter which way they go. There's no polarity issue. I think that one's sticking up in the air slightly, so bit of pressure. There you go, and it clips down. You can hear it and you can feel it click down when you reheat the solder, and that just makes sure it's nice and flat on the board. And resistor 12. You seeing this? I do hope so, otherwise it's all going to be a bit pointless, isn't it? Resistor 12. And again, a little bit of pressure, reheat, and pop. It pops into place. Don't always get these things straight, unfortunately, but do you know what? It shouldn't matter. And then, having done all of that, it just remains to solder the other side of the component. Like that. And then with these three, there we go. And those very tiny components may seem rather daunting, but to be honest, they are dead easy. The trick is to have a fine point on your soldering iron and some fine point tweezers, and that's all you need, and they are on there quite happily. So what I'm going to do is do all the other resistors and the little capacitors. Again, the capacitors don't really matter which way around they go. They're not reliant on polarity either. Those are the capacitors, they're not even numbered. And I don't think they matter too. There are, these, what are these? These are, what does that say? Let's focus in. 103s, they're going to be resistors, I would have thought. 104s. Do you know, that's interesting. I cannot see. Is that definitely 103? It does say 103. I'm pretty sure it does. I know my eyesight is rubbish, but there is no component marked to 103. Which would be, I think these are going to be resistors as well, but I cannot see 103s on the listing. I can see 104s, but they're a chip capacitor. I'm going to have a look at that. Anyway, so let's get these components all installed, and we can move on to more interesting things like these nice big 10mm LEDs. So back soon. Right, so what have I been up to? Well, I'm not telling you that, but in the meantime, I'll tell you what I've been doing with this. We have got capacitors installed there, and we've got all the resistors, 121, 121, 121, 103. These are 10Ks. That means 10 and 3 zeros. Up here we have got a 102, which is a 1K, so it's a 10 and 2 zeros, and 121, 120 ohms, I think, and another capacitor there. So let's crack on. Oh yes, and a couple more resistors here. What are they? I forget. 105, and they go there. Okay, so what's next? I think we've got, what do we got next? Oh, we've got this, U2, U. Just trying to think what U means. Is that a, is that one there, U? It's not, oh, I don't know, I can't remember. It's not a choke. It's not a coil, obviously. Oh, gold. I can't remember. At any rate, here it is. Where's it gone? It is there. So, get that into focus and do the similar approach to soldering. I mean, it doesn't really matter what order you put components in, but as I say, the most important thing is to put these in first, because they're the trickiest by a long way, and you don't want other components on the board which are going to make life difficult for you while you're putting those chips in. So that's why I always do those first. Right. We'll put that one in. Sorry for the silence, I can't multitask. Talking and soldering at the same time. Recipe for disaster in my case. Well, that's quite a big pad there. That's going to want a fair old bit of solder on it. There we go, that will do it. And so on and so forth. Now, there are a couple of components which I didn't realise it had, which will certainly enhance the aesthetics of the device, and they, where are they? I lost them already. No, there they are. There's a couple of tiny LEDs. Well, there's actually 3 LEDs here, but we only need 2 of them. I'm going to focus. Oh, good. The other way up. So yeah, it comes with 3 LEDs, the 3 tiny LEDs, which go between some of the 10mm LEDs. So we'll open these up. Now these are polarity critical, as with all LEDs, and the way that you know which way round to do these is, and let's get out the, I mean, opening the packets on these things is just apocalyptically difficult, and this is where you've got to be careful, because you start flinging them across the room. You will never find these if you drop them on the carpet. Never. Oh, for crying out loud, come on. This is ridiculous. I have no idea what you're seeing at the moment. a complete shambles, I shouldn't wonder. Let's see if I can cut them out with the knife rather than fiddling and farting about. I'm trying to open them neatly. Oh God, these things are absolutely... Am I in yet? I'm getting there. There we go. Right, okay. I'm just going to show you one of them. Well, first of all, what I'm going to do is... Okay, so we've got 2 of these LEDs that live next door to the main ones. Let's get this around the other way. Right, so I'm going to solder that pad there. And I'm going to do the same with that pad there. Now, as I said, these are polarity sensitive. Or if sensitive is the right word, but they are. Alright, you can see that. Let's see if I can focus on that. You can see that one side's got a green mark on it. And that green mark has to correspond with, although it's not printed very well, you can see that that silk screen print is thicker than that side, which means the green corresponds with the thicker side. So let's put these in. Now the thing is with these tiny little LEDs is that you really don't want too much heat on them, so you just really want to whack them in as quickly as you can. That'll do. Let's get one more out and do the other side. What these LEDs actually do, I have no idea until I read the instructions in a bit more detail. But at the moment, let's just focus on construction. So, come on. And these are so tiny. Right, and this one's gonna... How's the focusing doing? There we go. And again, whack them straight in. Try not to put too much heat on the LEDs because you will... Oops! Told you I can't talk and solder at the same time. So I'll try that again. Oh, rats. Well, this one's had loads of heat applied to it. That'll probably be okay. Right, try that again. Oh, good. God, it's taken the pee. Right. Wow. That was more difficult than it should have been. I don't even know if you saw any of that. Hope not, because it was me completely making a mess of trying to solder a tiny little LED. And so I think it's the cathode side that is the green side. Anyway, so there you go. You didn't see that second one, did you? I don't know. There it is. See if I can bring it a little bit closer up. And hopefully you can see. Might even be better if I turn the light off. You can see the green goes to the right on both of them. Okay, so the rest of the components, except for one set which I think are a bit more interesting because I don't think I've ever used these before, but we'll come on to that in a minute. The rest of the components, like the buzzer, which is also polarity sensitive. You can see it's got a plus there, and I can't remember which side. I think the negative is the square and the positive is the plus. I'm not even too sure I'll solder this in because frankly I ain't going to use this as an alarm clock and I find them a pain in the arse. I might put it in. And then we've got these capacitors here, one there, and a smaller one there, which go there and there respectively. So they're all fairly straightforward, nothing weird and wonderful. We've got the battery connector, which will sit like that. And I'm not sure what size battery these are. I might have some. They might be CR 2012s or 2102 or something like that. I might have some of those, but obviously that's to maintain the time. I'll probably steal it out of another clock I've made. And then the LEDs, and of course we also have the photoelectric cell, which I suspect will be for dimming the clock or dimming the LEDs when the ambient light is off or when the lights are off. I suspect that's what that is for. And what's that going to be for? Oh, that's probably that's going to be for the mini USB, which will sit in there like that. And they have supplied a mini USB plug. So I'm going to put in all of those components. There's also there's a couple of tiny chokes or whatever they are. I don't know what they are. Amplifiers possibly. Where do they go? I can't see where they go. I'll find it in a minute. Was it there? No, it can't be. There's only two connect. Oh no, that's the photoelectric cell there. Or I'll find it and I'll go through the entire board. Oh, there it is. Q1. So one of them goes there, but I've got two. So I'm going to install all of those straightforward components, and once I've done that, I will come back to you. Right, many things have been soldered. We have soldered the battery holder, the buzzer, the photoelectric cell, the micro USB jack, the two capacitors, and I think that's about it, apart from the fact that we've got two mercury switches, which I didn't realise. I showed you one earlier, but there was two in there. And the reason being is that the idea is that you tilt the clock towards you, or it's probably going to be that way, isn't it? You tilt it towards you, and that means then you can start setting the time and da-di-da, and you tilt it away from you and you set the alarm. And obviously the tilting is quite important, because one micro switch will do one function, the other mercury switch rather will do the other function, and they've got to be at 45 degrees, and I'm just eyeballing it, but you get the general idea. So they have to be like that, roughly like that, so it follows the orientation of the tilting depending on what function you want. So that's the purpose of those. All we're left with, I say not all, we've still got all the hardware to do, the case and all the rest of it, and of course we've got these little glass files or bottles or whatever you want to call them, which go over the LEDs, but we'll worry about that later. We need to make sure this thing works first. But of course now we have the final bit, which is the 10mm LEDs. Now obviously they go here, and you'll see that one of the legs is longer than all of the others, and that long leg will go in the square hole. So it's obviously a through hole device, and you can see that you've got 4 holes there for each LED, and one of them is square, and it's the square one that accepts the longer leg. So in this case it's going to go in like that. I should have probably splayed the legs out a little bit before I do this, but you get the idea. So one goes in there, and then the fourth one will go in there, and I guess we'll just bring them right down. I don't know if we bring them right down to the base or not. Let's have a quick look at what there are photographs in the no, they're probably about that. You don't want to force it too much because you could be in planet damaging then. So just make sure it's kind of straight and like that. Solder it all up. Snip the pins off, and you're good to go. And I think once we've done that, we can actually power it up and just to test it's working before we bother putting the glass files on like that. So yeah, let's get these 10mm LEDs on and then we'll power it up. Right, the LEDs are now suitably soldered in. Try to get them roughly the same height and roughly vertical. And there was also a spare one, which was nice. So if one of them's duff, then at least we've got a way of replacement. So there we have it. It is virtually complete. We've got the photoelectric cell in there. Yeah, it just remains to power it on. So this is connected to power, so well, it's not muck about. Let's see what happens. Ooh, we have life, and it is doing something, which is always good, I believe. Let's zoom out, but I don't know if the lighting trouble is it looks a bit washed out, so that's changing all sorts of colours. We've got that LED is flashing occasionally. That one's doing nothing. Oh no, that one is on. No, that one is on. It's a blue LED, but it's not. That one's not doing anything, but I don't know if it's supposed to be doing anything at this point. Now of course there is also the, so that way is probably setting alarm, and this way would be yes. So I've done something there, and that is cycling through the colours of this end one. When I do that, I haven't got a clue what I'm doing at the moment, which is basically means situation normal. But I'm going to say that that's working, although that LED there, I don't know if that's supposed to be doing something. It's doing a very good impression of not at the moment, so I might need to, it might be that it's perfectly okay and it's just not meant to be on. I don't know. And that one has actually stopped flashing now as well, so I don't know. Okay, right. The next thing to do is that's good enough to say, right, success. Let's finish building this, which means bringing in all the hardware to then put on the bottom case, and also the glass files. Now the glass files, which sit on like that, I do wonder if I've put those LEDs too far down. Actually, they would have been better further up, wouldn't they? Guess what? It's too late now. I'm not changing it. Well, I can't change it because I've shortened all legs. So yeah, when you do yours, it would be better if the LEDs were further up and perhaps filling more of the glass bottles. I mean, they're only there for show anyway. They say it protects the LEDs, but these things are as robust as hell. So yeah, they recommend that you glue these on with an epoxy or with a hot glue gun. I shall use a hot glue gun. They say do not use super glue, because the super glue, probably because of the vapors it creates, can make the glass misty. So don't use super glue. Hot glue gun, probably the way to go. It's certainly the way I'm going to go. So let me do all of that. Hardware, get the bottles on, and then we'll have a look at the kit and see if we can work out how to configure it. And here is the completed kit. I've stuck the glass covers or files or bottles, whatever you want to call them, on using hot glue, and that seems to have worked quite well, although I wouldn't put too much pressure on them. I think because you've got smooth glass, you've got a smooth surface on the on the PCB, so I think they'll pop off reasonably easily. A stronger epoxy might be a better option. We've got the acrylic bottom attached with the brass standoff, so that works quite nice. You can see the mercury switches there at roughly 45 degrees, but they'll only go so far any rate because of the acrylic case. These little LEDs here, they indicate that the alarm is switched on. The way that the clock actually works is that each colour represents a number. So the colours are white, red, orange, yellow, green, indigo, cyan, blue, purple and pink. And that's 9 colours representing the numbers 0 to 9. So for example, that one is, was that, I don't know what that is. I can't really tell the difference between yellow and orange, to be brutally honest. But that one's definitely green. So that's 1, 2, 3, 4, 5. So that'll be 5. So that will be a 5, and you get the idea. So you'd need to remember the numbers and their associated colour to be able to tell the time. And I dare say if you sort of really studied and looked at it hard enough, then yeah, you probably get it. These two represent the hour, these two represent minutes, and these two represent seconds. If you put the thing upside down, it then goes into a binary mode. I don't read binary, so I don't know how that works, to be brutally honest. You can see that doing whatever thing it's supposed to do in binary. To actually change the time, this is where the mercury switches come into being. If you tilt it backwards, you then start setting the clock, the alarm time, and if you tilt it forward, you then go into the normal time. And the idea is that the other thing is that if you just press one of these switches, these two light up, and these represent the temperature in degrees centigrade, so whatever the colours are here will tell you the temperature. The one thing I'm finding is that it is horrifically difficult to get it to do anything. The touch, there you go. Now you can see that is now flashing, and it moves on to the next one, and then like this, and you can change the colours, but it tends to I don't know what's going on here. You can see that left hand blue LED, that little one, is going on and off every time I think I don't know what that's setting really, but there you go, it's flashing, and you press to change onto the next LED, and then you can press to change the colour. But it seems to be a bit intermittent to me. I'm not entirely convinced that the touch controls work. Give me, well, they work, but I don't think they work very well. Give me good old-fashioned ordinary buttons any day of the week. But I'm not bothered setting it all up, because frankly, I'm not going to read the time using colour. But it's a nice thing to look at. It really is quite a nice thing to look at. In terms of whether it's a good kit, yes, I think it's quite a nice quality kit, nice PCB. Bear in mind it is mostly surface mount components. If you're not into surface mount, let's get a bit more light on it. If you're not into surface mount soldering, then it's probably not one for you. Yeah, well, I should have cleaned off all that flux. Ugh. Oh, never mind. It's not the most straightforward one when it comes to soldering if you're not used to surface mount, but outside of that, it's probably a good kit to either way, and it's certainly a nice thing to look at. So there you go. I hope you enjoyed this video. As I say, it did bang on a bit, but I have got some other kits. Hopefully something a bit more different. I'm trying to find something a bit different to the normal clocks and that sort of stuff, but this was a little unique. and I'm going to try and find stuff like this if I can, but we shall persevere. So I hope you enjoyed this video, and we will catch you on the next one. In the meantime, have a good summer, because the summer's coming up. I should have some more videos before the summer's out, that's for sure. I don't sort of crank these videos out as fast as a lot of people do, because you know I'm not doing this all the time, but I hope you enjoy what I do. In the meantime, cheers for now.